In this video, we're going to talk about how to complete the square. Before we do that, let's talk about the three forms of a quadratic function. They are standard form, factored form, and vertex form. Sometimes vertex form is called graphing form. Now, why might we want to switch between forms? Well, vertex form is nice because it's helpful for graphing, and it's helpful because when it's in vertex form, we can read off the vertex being the point h comma k. It's also nice because we can look at the leading coefficient, which is a, and it will tell us if our parabola is opening upwards or downwards, depending on whether a is positive or negative. So completing the square, it turns out, is the process of taking a quadratic in standard form and converting it into vertex form. So let's go ahead and see what that process looks like. I have some shapes down here, and suppose I wanted to find the area of each of these shapes individually, and then I wanted to add them all together to find the total area of all of these shapes. I'm starting off with a big square. I don't know what its dimensions are, so I'm just going to give its dimensions the variable x. So x is just representing some number, and the area of this large square is x squared because I'm multiplying x times x. That's the formula for the area of a square. Now, next to this big square, I have some skinny rectangles, and the dimensions of these skinny rectangles are, this is going to be 1, and then the height of these skinny rectangles is also going to be x, just like the big square from earlier. That means that if I wanted to find the area of each of these skinny rectangles, I would multiply its width times its height, which is going to give me x. So all of these rectangles have an area of x. At the end here, we have this final tiny square, and its dimensions are 1 by 1, so its area is going to be 1 unit squared. Now, let's go ahead and add up all of the areas to get the total area of all of these shapes. So I'm going to have x squared plus, and then the number of skinny rectangles that we have is 8 of them. And so we have 8 plus 8x, and then plus 1. So hopefully you're trying to, or able to, see the connection now between quadratic functions and these geometric shapes. So the total area of these geometric shapes is x squared plus 8x plus 1. Now you might have wondered at some point, why is the process called completing the square? We're going to use a visual to help us with that. Suppose I wanted to take these individual shapes and I wanted to arrange them so that my goal is to create a larger square. Here's what that would look like. So here I've stacked my individual shapes in a way that I'm trying to make a larger square. And notice that the dimensions here, because I have 4 of the skinny rectangles stacked this way, this is a length of 4. And then I have 4 of the skinny rectangles stacked this way. This is also 4. So notice that if I were to have that larger square, its area would be x plus 4 times x plus 4, which is equal to x plus 4 quantity squared. Now in reality, I don't actually have, I like to call these things ghost squares. And how many of them are there? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there's 15 of these ghost squares. So in reality, my total area is actually not x plus 4 squared. I have to account for these ghost squares, and there are 15 of them. So I'm going to subtract off 15. So from earlier, we have x squared plus 8x plus 1, and it turns out that that's equivalent to x plus 4 quantity squared minus 15. These two quadratic functions are equivalent to each other because what we did was we found a total area in two different ways. And so that's how we know that these are equal to each other. But how do I get from here to here? Here's a more systematic way of doing that. So I have my x squared plus 8x plus 1. I'm going to move the plus 1 out here, and I'm going to put parentheses right here. So now what I want to do is I want to take my coefficient of x, which happens to be 8 here. I want to take 8 and I want to cut it in half. And notice we're cutting it in half because I put half of my skinny rectangles here and I put half of my skinny rectangles here. So that's why we are cutting it in half. And then the next thing that I want to do is I want to square this. And if I do that, 8 divided by 2 is 4, and 4 squared is 16. And 16 represents the number of tiny squares that we would have, because this is 4 by 4. So 16 represents the total number of tiny squares that we need. So what I'm going to do here is I'm going to put plus 16 here. But I can't just randomly add 16 out of nowhere. That would change my function. So what I need to do in order to maintain balance is I need to, out here, subtract 16. Because if I add 16 and subtract 16, that is the equivalent of adding 0. And adding 0 doesn't change my function. So now what happens is the thing inside of my parentheses can be factored, and it factors into x plus 4 quantity squared. And then the outside, if I have 1 minus 16, that simplifies to minus 15. So that kind of describes the process of how we go from standard form to vertex form, which again is called, that process is called completing the square. Let's go ahead and take a look at some more examples of completing the square. Example 1 says convert the following quadratic functions from standard form to vertex form. So in part A here, what I want to do is, just like we did previously, I want to take the b value, or the coefficient of x, which in this case is negative 14. Then we want to divide it by 2, or cut it in half, and then square it. So that's going to be negative 7 quantity squared, which is equal to 49. So now I'm going to take my quadratic, and inside my parentheses, I'm going to write x squared minus 14x. I'm going to leave a blank space, and then I have minus 3 on the outside here. So based off this number, I'm going to add 49, and then on the outside, again to maintain balance, I need to subtract 49. And so what happens is the thing inside of our parentheses, this factors into x minus 7 quantity squared, and then negative 3 minus 49 is minus 52. And so this is our final answer for part A. For part B, we have y equals r squared minus 2/5 r. And I'm going to go ahead and put parentheses around this. And to figure out what I need to add inside of my parentheses, I'm going to take our b value, which in this case is negative 2/5. And I want to divide that by 2, which is the same thing as multiplying by 1/2. And then I want to square that. So what's going to happen is the 2 in the numerator and the 2 in the denominator is going to cancel out. And we have negative 1/5 quantity squared, which is going to equal 1 over 25. So inside my parentheses, I want to add 1 over 25. And then outside my parentheses, to maintain balance, I want to subtract 1 over 25. And coming down here, we have y equals, and then we're going to have r minus 1/5 quantity squared minus 1 over 25. And that will be our answer for part B. All right, part C is the first example that we've encountered where our leading coefficient, or our a value, was something other than 1. So how do we deal with that? Well, what I'm going to do is I'm going to factor out a 3, the leading coefficient, from the first two terms. So that's going to leave me with x squared, and then negative 18 divided by 3 is negative 6, so I'm going to have minus 6. And then I'm going to leave my blank space, and then my parenthesis, and then I'm going to rewrite the plus 15 there. And I don't want to factor out my leading coefficient from the constant term, so I'm just going to leave that as is. Now what I want to do is I want to take my b value again, which is in this case negative 6, and then I want to cut it in half, and then I want to square that. So negative 3 divided by negative 2 is negative 6 divided by negative 2 is negative 3. I square that, that gives me 9. So inside of my parentheses, I'm going to add 9. And then the place where this changes is I don't want to subtract 9 on the outside of my parentheses because I'm not actually adding 9. What I'm really adding is 3 times 9, which in this case is 27. So I actually, on my outside, I want to subtract 3 times 9, which is 27. So coming down here, we have y equals 3 times x minus 3 quantity squared, and then 15 minus 27 is negative 12 or minus 12. So here is that, and that's our answer for part C. I mentioned earlier, one of the reasons why we might want to go from standard form to vertex form is to help us graph the parabola. Another reason why we might want to do that is it sometimes helps us to solve quadratic equations. Now, there's different ways we can solve quadratic equations. One of the ways is using the quadratic formula, but here in example 2, this is going to ask us to solve each equation by completing the square. So let's see how we do that. For part A, we have 10b squared minus 20b minus 72 is equal to 8. What I'm going to do is I'm going to start off by moving my constant term on the left-hand side to the right-hand side of my equation. And that's going to give me 10b squared minus 20b is equal to 80. And the next thing that you might notice is our leading coefficient on the left-hand side is not 1. So just like we did previously, I'm going to factor out my leading coefficient. And that's going to leave me with this. And I'm leaving this blank space here because now we're going to complete the square like we've done previously. So I'm going to take my b value, which is negative 2 in this case. I'm going to divide it by 2 and then square it. So negative 2 divided by 2 is negative 1. I'm going to square that, and that gives me 1. So in my blank space, I'm going to put a plus 1. And on what's really happening is I'm not actually adding plus 1. Really, in reality, I'm adding plus 10. And what's nice here is we have an equal sign. So if I'm adding 10 on the left-hand side of my equation, if I add 10 on the right-hand side of my equation, I should still have equality. So from here, I have 10, and then I'm going to factor the thing inside of my parentheses, and that's going to factor into b minus 1 squared. The right-hand side will simplify to 90. From here, I can divide both sides by 10, and that's going to give me b minus 1 squared is equal to 9. From here, I can take the square root of both sides, and that's going to give me b minus 1 is equal to 3, and b minus 1 is equal to negative 3. If I add 1 on both sides, for both of these equations, then I'll get a solution of b equals 4, and my other solution will be b equals negative 2. So that is how you can solve a quadratic equation by completing the square. Let's move on to part B. I'm going to subtract 18 from both sides, and if we do that, we get negative 2r squared plus 20r is equal to negative 4 minus 18 is negative 22. From here, I'm going to factor out my leading coefficient. Okay, So let's take our b value, which is negative 10. I'm going to cut that in half and then square that. Negative 10 divided by 2 is negative 5. And that's going to give us 25. So here I'm going to add 25. But if I distribute my leading coefficient, negative 2 times 25, it's really like I'm subtracting 50. So on this side, I need to subtract 50. Okay, so now I get negative 2 times r minus 5 quantity squared is equal to negative 72. From here, we're going to divide negative 2 on both sides, and that's going to give us r minus 5 quantity squared is equal to 36. Then we can take the square root of both sides. We'd get r minus 5 is equal to 6, and r minus 5 is equal to negative 6. So we get r equals 11, and r equals negative 1. And those are our solutions for part B. All right, so for part C, we have 9k squared minus 18k. I'm going to go ahead and subtract 14 from both sides. And if we do that, 9 minus 14 will give us negative 5. Then I want to factor out my leading coefficient. And from here, I want to take my b value, which is negative 2, cut it in half, and then square it. That's going to give me negative 1 squared, which is equal to 1. So here I'm going to add 1, and then if I distribute the 9, that means we're adding 9 to the left-hand side, so I'm going to add 9 to the right-hand side as well. So then we get 9 times the expression inside of our parentheses. We'll factor into k minus 1 squared is equal to 4. Then I can divide both sides by 9, and we get k minus 1 quantity squared is equal to 4/9. If I take the square root of both sides, we get k minus 1 is equal to positive 2/3, and then k minus 1 is equal to negative 2/3. Then I can add 1 on both sides, and we get k equals 2/3 plus 1 is the same thing as 2/3 plus 3/3, which is equal to 5/3. And then our other solution is k equals negative 2/3 plus 1 is the same thing as 3/3, so that's going to give us 1/3. So 5/3 and 1/3 are our answer for part C. And that concludes this video.